Okay, so let's summarize, right? We got the subatomic particles, protons, neutrons, and electrons. Okay, let's look at their masses. And you can find these too. You don't have to memorize these, right? If you ever need it, it's going to be on your conversion sheet. Okay, so the mass of the proton is 1.67262 times 10 to the minus 27 kilograms. Okay, the mass of the neutron is 1.67493 times 10 to the minus 27 kilograms. So very close, right? Mass of proton and neutron are nearly identical. And then look at the mass of the electron, 0.00091 times 10 to the minus 27 kilograms. So tiny compared to proton and neutron. So that's why when you're calculating the mass of an atom, just ignore the electron, right? It's effectively zero, right? Of course, it has a mass, but it's just so light that it doesn't really contribute to the mass of the entire atom, okay? So we can just ignore it. All right, so here's a table that summarizes everything, right? You got the mass, and these masses are very cumbersome, so we normalize it to what's called the AMU, stands for atomic mass unit. So the proton has atomic mass unit of roughly 1, neutron is 1, electron 0, okay? Their charges respectively, the proton is 1 plus, neutron 0, and the electron is 1 minus. And then here you see the charge as well, right? That was determined by uh, Millikan, right? So proton has this charge, positive, right? Well, the electron must have the exact same charge to be able to neutralize it out, but just opposite sign, okay? So, and then the neutron, 0. That's why it's named neutron, right? Neutral. All right. So let's move on. So now we know the anatomy of the atom, right? Let's talk about elements. Okay. So there are, many different elements, right? 100 plus, and it's growing, right? Um, but they are defined by their number of protons. The number of protons is basically like the DNA of the element, right? What makes the element unique. Okay. Um, and the number of protons has a term. It's called the atomic number. Okay, so the atomic number is the same thing as the number of protons, and it has a symbol Z, capital Z. Okay, so Z is the number of protons, and it defines the atom, right? So if we're talking about helium, and you can look on your periodic table, you can find the atomic number above the element symbol. So you'll see that it's 2. That means helium has 2 protons, and if something has 3 protons, then it's not helium, right? Because that's the DNA. That is the what makes each element what it is, right? Unique. So helium is 2 protons. Carbon has to be 6 protons. If you're not 6 protons, you're not carbon, right? You're something else. Okay. So the number of protons defines the element. Does that make sense? Right. Okay, so if you look at your periodic table, and you should use the one that I have on Canvas, scroll to the very bottom under modules, you find that periodic table. You should use that one because that's the one that you're going to be allowed on quizzes and exam. So all periodic tables now look very similar, right? You have this structure, um, and you always have the chemical symbol. It's either 1 letter or 2 letters, with the first letter always being capitalized. It's really important that you guys write it that way too, okay? Otherwise, it's gonna look not like an element, okay? So you must capitalize the first letter. Your next job to do is connect the chemical symbol to the name, okay? So we have right now on this periodic table 103 elements, okay? Um, you don't need to know all of them, but I would say go to 92 at least. Okay, go to the last naturally occurring element. Okay, so you got 92 elements and symbols to learn. Quickest way to do this, there's probably an app that allows you to do this. But flashcards, something like flashcards where if I say molybdenum, you got to know that it's MO, right? Or if I say arsenic, you got to know that it's AS. Okay. And if I say, what is Cu, you say copper. Okay. So you want to know those. Okay. And then the atomic number, the number of protons you can find above the chemical symbol. Okay. So you'll always see that right in each periodic table. Okay, so chemical symbol is always one or two letter abbreviation, and remember to capitalize the first letter, right? Helium is He, carbon is C, nitrogen is N, right? Sometimes it's just one letter, but make sure you capitalize it. Okay, so all atoms that are of the same, of a given element have the same number of protons, okay? So, however, they don't have to have the same number of neutrons. And this is what we call isotopes, okay? So again, isotopes have the same number of protons, but different number of neutrons, and therefore different mass, right? Because remember, each of protons and neutrons is 1 AMU. So same number of protons, different number of neutrons is what we call isotopes. Now, every element on the periodic table will have different isotopes. Some have less, some have more. Tin, I think, have like almost 20 different isotopes, whereas neon only has 3. Okay, there are only 3 isotopes for neon. So all neon atoms, right? They must contain how many protons, guys? Look at your periodic table. It should be 10, right? But they may contain 10, 11, or 12 neutrons. Okay, so how would you um write that? Let's switch to here. Write the different isotopes of neon. You go neon -10, neon -11, and neon -12. Okay, that's the notation, one of the common notations you're going to see. And I'll show you in a second the AZX notation. Okay, so now not all isotopes are created the same. There are isotopes that are going to be more stable than others. And it's just going to be dependent on their natural abundance. And natural abundance is, how they're found in nature, right? So the percentages of isotopes is called the natural abundance, and the one that's present in the most is always the most stable, okay? Now to represent isotopes, I call it the AZX notation, right? So the AZX notation, go back to the board. This is the chemical symbol. This is the mass number. And this is the number of protons. Okay. So that means if you want to know the number of neutrons, all you simply do is take the mass number, subtract the number of protons. Okay. Because remember, the mass of an atom is only determined by proton and neutron, right? So mass is equal to P plus Z. And the mass number is A, right? Okay. So that means if you want to know, sorry, P plus N, number of neutrons. So if you want to know the number of neutrons, you just take A minus Z, okay? Because the number of protons is Z, okay? So let's try it. For neon 10, this is how you would write it. The chemical symbol is neon. 10 is the mass number, okay? So 10 go up here. And how many protons does neon have? Also 10, right? So neon 10 has 0 neutrons. It's 10 minus 10, right? But neon 11, let's see. Oh, sorry. I think I wrote that down wrong. So neon has 3, 21, 22, 20, 21, and 22. Okay. So those are the 3 isotopes of neon. So let's do it again. We'd have neon 20 is the A number, and 10 is the number of protons. So if you want to know the number of neutrons, you just take 20 minus 10, which is 10. Right? For neon 21, the mass number is 21. You still have 10 protons, right? So 21 minus 10 is 11 neutrons. Okay. Then neon 22, 10, 12 neutrons. Okay. So that's how you figure out the number of neutrons, right? You take the A minus Z. Okay. And the way you read this, these three isotopes, you just read the symbol and the mass number. So this is neon 20, neon 21, and neon 22. Okay. And this is another way to write isotopes, right? So here, it doesn't give you the number of protons, but you can figure it out, right? You just look at your periodic table to know that neon has 10 protons, right? So that's another way, second common notation to write isotopes. Okay, yep, so that's the second way to write isotopes, chemical symbol, and then the mass number. Okay, so now if you look at the natural abundance, you'll see that neon 20 is the most abundant. Just find, if you take a sample of neon in nature, you'll find that it's 90.48% neon. And so that means neon 20 must be the most stable, right? It means the other neon 21, 22 are actually radioactive, right? It's probably being turned into neon 20. That's neon 20. It's the most stable. And then after that, neon 22 is next, right? At 9.25%. And then neon 21 looks like it's the least stable and the least abundant, 0.27%. Okay. Okay, let's do this example problem together. What are the atomic numbers Z, mass number A, and the symbol of chlorine isotope with 18 neutrons? Chlorine with 18 neutrons. All right, so you guys can answer this, right? Get out your periodic table. Chlorine is what symbol? Cl. So we do that first, right? So then now figure out its number of protons. Okay, so that's 17, right? Looking at the periodic table, right? And if it has 18 neutrons, then what is its mass number? Well, mass is neutron plus proton, so 18 plus 17 is 35. Okay, so there we go. We got the A and the Z. Okay. Okay, that was part A. Part B. How many protons, electrons, and neutrons are present in 5224 CR? Okay. All right, what's CR, guys? What's CR? It's chromium, right? So you should know that. Okay. Now it wants to know the number of protons. So where's protons written at? This bottom number, 24 protons. Okay. And then it wants to know the number of neutrons. Okay. Number of neutrons, remember, just take 52 minus 24. That's 28. Okay. So we have 28 neutrons. Okay. And then it asks how many electrons. Well, remember, this part is easy because the atom should have the same number of electrons as it does the protons. Otherwise, it would be unstable, right? It has to neutralize out. So for a neutral atom, 24 protons, it also must have 24 electrons, right? Because a positive and negative charge got to balance out, okay? So that's pretty straightforward to figure out electrons. It's going to be same as protons. The atom is neutral, okay?